Welcome students to the quick solution of All India Akash test series medical for OYM and carried forward. This is test number 6 code A and B for chemistry conducted on 3rd of January 2021. So let's begin with the first question. Let's read it students. An open vessel at 300 Kelvin is heated till 1/5 of the air is expelled. Then final temperature of the vessel is. Student, here it is an open vessel. That means the formula used is N1T1 is equals to N2T2. We are given with T1 which is 300 Kelvin and we have to calculate the final temperature. That means we have to calculate T2. Here it is given that on heating 1/5 of the air is expelled. That means we can find out the relation between N1 and N2. So student, N2 is equals to N1 minus 1/5 of N1. Since 1/5 of air is expelled out, so the remaining will be 4 upon 5 N1. So let's put the value of N2 in the equation. We'll get N1, then T1 is 300, N2 is 4 upon 5 N1 multiplied by T2. We have to calculate T2. So let's cancel N1 with N1. So T2 is equals to 300 into 5 upon 4, which is equals to 375 Kelvin. That means the correct answer is option number 1. Here I'm writing answer is option number 1. Moving to next, which is question number 47. Let's read this. A gaseous mixture contains 80% CH4 and 20% H2 by mass. Density of this mixture at 27 degrees Celsius and at 760 mmHg is. Student, in this question, the formula used is density is equals to Pm upon RT. Here we are given with a mixture of CH4 and H2. So here the molar mass used is of the mixture. Here I'm writing molar mass of mixture. So let's calculate the molar mass of mixture. First we'll be calculating number of moles of CH4 and number of moles of H2. So number of moles of CH4 is equals to given mass upon molar mass. So it is given that 80% of CH4 is present. That means if we take 100 grams of the mixture, so 80 gram of CH4 and the molar mass of CH4 is 16. That means 5 moles of CH4 are present. So let's calculate number of moles of H2. Since 20% of H2 is given, so let's assume 20 gram upon 2 gram. That means 10 moles of H2 are present. So student, that means total moles is equals to 15, 10 plus 5, and then we'll be calculating the molar mass of mixture, which is equals to given mass upon number of moles total. So mass we have assumed 100 and total number of moles is equals to 15. We have already calculated, which is equals to 6.66. Let's put the value of molar mass of the mixture in the first equation. So density of mixture is equals to pressure, which is 760 mmHg, that means 1 atm. So 1 multiplied by molar mass of mixture, which is 6.66 upon R. So the value of R will be 0.0821 liter atm per Kelvin per mole. And the last is temperature, which is 27 degrees Celsius. That means in Kelvin, this will be 300 Kelvin. So multiply this with 300. The answer will be 0.27 gram per liter. That means the correct answer is option number 1. Here I'm writing answer is option number 1. Moving to next question, which is 48. Let's read it. CO2 and an unknown gas X diffuse the same volume through a pore in 40 and 20 seconds respectively. Molecular mass of the gas X is. Student, so for this, for such questions, the formula used that relates rate of diffusion or effusion with the volume and time is given as rate of CO2 upon rate of diffusion of an unknown gas X is equals to volume upon time for CO2, that is volume of gas diffused in time t for CO2 upon volume upon time for the gas X. which is again equals to under root of molar mass of X upon molar mass of CO2. Now students, here we are given that the volume is same. That means the formula becomes time required for gas X upon time required for the gas CO2 is equals to under root of molar mass of X upon molar mass of CO2. Now students, we are given that the time required by CO2 is 40 seconds and the time required by the gas X is 20 seconds. So let's put the value. 20 upon 40 is equals to under root of molar mass of X upon molar mass of CO2 is 44. Now students, let's solve this question. Molar mass of X is equals to 11 U. That means the correct answer is option number 3. Students, in such question, use different techniques to solve the question. Avoid using calculators for such questions. You need to practice questions. Moving to next question. Question number 49. Let's read it. At which temperature the total kinetic energy of zero point 0.2 mole of H2 gas be the same as that of zero point 0.4 mole of O2 gas at 300 Kelvin? Student, we all know that kinetic energy is equals to 3 by 2 nRT. Here we are given two gases H2 and O2 with zero point 0.2 moles of H2 and zero point 0.4 moles of O2. Also, we have to answer the temperature of H2 and we are given with the temperature of O2, that is 300 Kelvin. So we are given that kinetic energy of H2 is equals to kinetic energy of O2. That means 3 by 2 nRT for H2 is equals to 3 by 2 nRT for O2, which means let's put the values. Number of moles of H2 is zero point 0.2. We'll cancel out 3 by 2 and we'll cancel out R. The temperature for H2 we have to calculate. Here number of moles of O2 is 0 0.4 and the temperature for O2 given is 300 Kelvin. So we can calculate temperature of H2 zero point 0.4 into 300 upon 0 point 0.2. So 2, that means 600 Kelvin. So the correct answer is option number 4. So answer I'm writing. Answer is option number 4. Moving to next question, which is question number 50. Let's read it. When temperature of a gas increases from 27 degrees Celsius to 127 degrees Celsius, the average speed of the gas molecule. So here I'm writing the formula to calculate U average. U average, that is average speed, is equals to under root of 8 RT by pi m. So the temperature has changed from 27 to 127. That is, let's convert this into Kelvin, 300 Kelvin to 400 Kelvin. So student, it is very clear that U average, let's take initial as 1 and U average, the final at temperature 400 Kelvin as 2 is equals to under root of initial temperature which was 300 upon the final temperature which is 400. That means we have to calculate the average speed. So let's cancel out 0. So U1 average upon U2 average is equals to root 3 upon 2. We are asked that the average speed of the gas molecules at temperature 400 Kelvin. That means we have to answer U2 average is equals to 2 upon root 3 U1 average. That means the final average speed becomes 2 upon root 3 times of the initial average speed. So the correct answer is option number 2. Here I'm writing. Answer is option number 2. The average speed becomes 2 by 3 times of the initial average speed. Moving to the next question.